Hi everyone, welcome to Litmus Test. Today we're going to start off looking at something very simple, very basic, the states of matter. Now don't turn off just yet. We're going to go a little bit more in depth than most of your previous science classes have talked about. I know a lot of people get this thrown at them a lot. It happens in your elementary school science classes, you see the magic school bus, you see it again in 10th grade, but we're going to talk a little bit more basic at first, but we're going to get to something that's a little higher notion of states of matter, something that actually matters to professional life and then actually matters to application. So let's start with the basics and we'll make it a little bit more advanced as we go. Three states of matter that everybody knows are solids, liquids, and gases. We start off with all the solids. All the solids that we walk on, the solids that we build. Generally, we expect solids to do things like fall, although this isn't the best way to demonstrate falling, since not everything falls, but we expect solids to be things that we can't move through, right? They take up space. So critically, we say solids have a volume, and we also say solids have a mass. This mass is what allows them to fall. Well, it's part of what allows them to fall. Oh dear, I'm gonna need that in a moment. Liquids are things that fall, but they also flow. A liquid does take up space. This space is taken up, and if I place something else there, it displaces the liquid. Also, the liquid will roll over solids and through small pores, but it flows, it moves, and just as it moves, it can push things. Again, like solids, this indicates that it has mass as well as volume, which shouldn't surprise us. There are states of matter at all, not states of energy, and so we expect these things to have mass, and we expect them to have volume. But, unlike a solid, where a solid's volume is set, and a solid's shape is set, liquids, well, liquids in Minecraft don't have a set volume. Liquids in real life do have a set volume, and they don't have a set shape. They can expand to fill their container that they're in. So I can place a liquid here, and it flows to fill this container. Of course, in real life, this wouldn't be flowing forever. It would equilibrate and settle itself out right there. But such are the limits of analogy. Let's look at gases. Well, yeah, gases are hard to see because gases don't interact with light very well, which is another topic we'll come back to, but a gas does still have mass and a gas does still have volume. Minecraft actually codes gases in an interesting way in that what we're looking at are air blocks. They're transparent, we can move through them, and they don't flow in the same way water flows, but they do get displaced. So when I place a solid block down, it's no longer air, the air moves out of the way or is replaced. But we can imagine that if there was a little bit of wind, when I put this down, we might feel a little puff. That's something to be expected. Air and other gases have mass and they have volume. As such, we can place them in gas tanks. Now, these are ways to compress air, and this gas tank might contain many, many, many blocks or buckets of air, and they can all be squished into one little spot. From here, a valve can be opened to release the gas. So gases have a volume, but they don't have a shape, and they don't really have a fixed volume. They have a mass that's fixed, but not a fixed volume. They have a volume, but it's not fixed. They have a mass, which is fixed, and they flow. So look at this again. We've got solids which have a fixed mass, fixed volume, don't flow. Liquids which have a fixed mass and a non-fixed volume. Well, mostly, and depends on whether we're talking about Minecraft or real life. And gases which have a non-fixed volume and non-fixed shape. They can flow, move, but they still have a fixed mass. There's a certain amount to it. Great, easy peasy, who cares? We care because of things or ways that we can interact between these phases. And because, well, not that, we care because of plasma. Everyone likes to talk about the mysterious fourth phase of matter, the fourth state of matter, as if it's mysterious and strange and otherworldly. And really what we're just talking about is a state of matter that is different from solids, liquids, and gases. And to understand how a state of matter could be different from solids, liquids, and gases, we need to understand what we mean when we say a phase or a state of matter. To do that, let's start by looking at some behaviors of liquids. So we're going to start with this concrete. We have a liquid concrete bucket, and the way concrete has been coated is that it flows, and then as it sits, it will harden, it will freeze. In real life, this involves a complicated chemical reaction, but in Minecraft, it is just frozen. There we go, we have frozen concrete. And this concrete is interesting that we can freeze it at different heights, and you can imagine we could pour this bucket over a wide area and watch it flow and freeze across an area. If I place it down, it will behave like any liquid in Minecraft. Well, most any liquid. You'll notice it's not infinite. And it will flow, and it will freeze. Again, the freezing isn't perfect, but that's okay. Also notice how it interacts with this water. Now this is not quite realistic because it doesn't sink as much as it should. I will have to replace all this. But it didn't really flow above the water either. So there was this transition between phases, that something started as a liquid and became a solid. We can see this as well with other liquids. Of course, the most well-known example, lava. In Minecraft, at least, when lava flows and meets water, the lava is cooled and forms stone. If we place the lava in direct contact with the water, if we place the lava block in direct contact with the water, it becomes obsidian. Everyone's least favorite block from classic Minecraft, I don't know, it's hard to mine, but in either case we're seeing water freeze. Well, lava freeze. If we want to see water freeze, we grab some ice, and ice has been a weird thing in Minecraft, right? If I take this ice, which we know is frozen water, and I break it, well, we don't get anything out of it, right? But we could melt it. We could melt the ice by sticking it near some heat source, and there are interactions which will cause the ice to melt and form into water. Now that takes a bit of time that we probably don't really want to sit here and watch the ice melt, but we know, Minecraft, there it goes, that it will melt over time. Alright, that was faster than I expected. We could melt the rest of this ice with some more lava, but you get the idea. Through the melting of that, we've also formed cobblestone, stone, and obsidian, all from the same two substances, lava and water. And this is where phase transitions get weird. Before we go any farther, there are a couple other phase transitions of interest. For example, there's boiling. Somebody has coded steam in here, although this steam does not behave completely accurately. Steam, of course, should rise, being a gas that is not going to fall because it's generally hot. Hot gases tend to rise. But at least it stays above the surface of the water, and that is accurate. And it does flow, which is also accurate. Oop. Other gases that we could create would be by boiling other substances, but they're hard to do. And so we're going to stick to just imagining our steam. It's lovely, I think. I do like watching it wander. Very nice. So, already we've covered the basics: solids, liquids, gases. And we've covered some of these ideas of phase transitions. This idea that you can move from one state of matter to another. It is possible to freeze liquids into solids, then melt solids into liquids. It's also possible to boil liquids and solids, or boil liquids. You can actually boil solids too. It's called sublimation. where you take a solid and move it directly to a gas. Minecraft doesn't have a good example of sublimation around, but we'll just have, and honestly there aren't that many examples in real life, but there is one. As the sun sets on us today, think about this, and we'll come back to this in the second video. Go to your fridge, go to your freezer, look at some ice. Look at some really old ice. Ice that you know you filled up the tray to the brim, and you had a bunch of ice cubes. Alright? Are they still cubes? Are they still as big as they were? You know they've been in the freezer, so they couldn't have melted. So what happened? Where'd the ice go? As you think about this, I'm going to wait for next time. Just look into more about phase changes, and stay tuned for the next video when we go a little bit more in depth as to what it means for a state of matter to be in a phase. What do we mean when we talk about other states of matter like plasma or really weird stuff? And what do we mean when we talk about phase changes? Until next time, folks, stay safe and don't catch on fire.